This is Narayana from Narayana Technology. So today's our topic is recursive functions here. So what is meant by recursive? Recursive is nothing but repetition. So what we are going to repeating a function. What is function is nothing but set of statements or instructions to be performed a particular task. So function repetition is called as recursive function. So the technical definition is recursive function is nothing but repetitively the function will be called by the function definition itself is called as recursive function here. Let us, for example, we return this function is called as f1 here. So once we write this function now, when this function will execute whenever we call this function. So let us, for example, if we call this function, then this function now will execute here. So let us, for example, we are writing this function. Once we write this function, whenever we are going to calling this function, then this function statements will execute. How many times this function will execute? Will execute only once. So when you call this function, then this function will be going to executing only once here. Okay. Suppose that if you want to repeat this function more times here, if you want to repeat more times, if you want to repeat this function more times here, then this function has to be, say when you call this function, function will execute. After execution this one, whatever we return the statements in this function definition, whatever we return the statements here, the statements we require to be repeat more times. If you want to repeat more times, then what should we do? Once again this function has to be called. So how will you call this one here? It has to be called by the definition itself only. This function is mechanism is called as recursive function mechanism here. So when you call this function, control is coming to the definition, execute the set of statements whatever we written in this function. After executing this set of statements here, again we are going to calling this function here. That is the same function. When you call this function, again the control is coming to the same definition and execute this statements here. So again it is going to calling this function. This process is going to repeating. How long it is going to repeating? It goes to repeat infinite times here. But we have to be stop this recursive function calling mechanism at certain time here. So then recursive function has to be stopped by using the if condition here. So this function can be stopped by using if condition here. So recursive function is nothing but repetition of the function definition by calling the function definition itself is called as recursive function. Repetitively the function will calls by the function definition itself is called recursive function. But this recursive function should be terminated by using if condition. And moreover, one more thing to be remembered, the recursive function is more efficient and reduces the length of the code here. So more efficient and faster and reduces the length of the code here. So that we'll discuss later in the example here. So let us, for example, if you want to be calculate factorial value as per the mathematical formulas, so that is factorial n is nothing but n into n minus 1 factorial. So let us, for example, if we take some example, that is n value is 5, n is equivalent to 5 here. So then now 5 factorial. 5 factorial is nothing but as per the mathematical process, that is 5 multiplication, that is factorial 4. Then this process is going to repeating again 4 multiplication factorial 3. Then again next time this is going to repeating this process. How long it is going to repeating? Next time 4 multiplication 3 multiplication 2. And next time this is going to repeating 4 multiplication 3 multiplication 2 multiplication 1. So next time it is going to stopping here. So this process here, what is going to happening here? First time it is going to 5 multiplied factorial 4. Next time 4 into factorial 3. Next time 4 into 3 into factorial, that is 4 into 3 into 2 factorial. And next time 4 into 3 into 2 into 1 factorial. And next time it becomes a 0 factorial. So it has to be stop this process here. So this is mathematically, that is whenever n value 0, then it is going to stop here. Now if let's observe this one, according to the, that is C programming, we can write this factorial is called as fact of n. Fact of n. What is fact of n? N multiplication fact of n minus 1 here. That is n equivalent to fact of n equivalent to n into fact of n minus 1. This mechanism, first time fact of n is nothing but fact of 5. 5 into fact of 4. Again it is calling the same function. Next time 4 into fact of 3. Next time 3 into fact of 2. Next time 2 into fact of 1. Next time 1 into fact of 0. So whenever n value is 0, then it is going to stop in this recursive function here. Say let us, for example, here we are just writing the function program, that is write a function to be written the factorial value of the number. Write a program that is function to be written the factorial value of the number. Okay, that is nothing but when this function has to be stopped, this one here. If n is equivalent to 0, then it has to be written factorial 0. What is factorial 0 is 1. Otherwise is nothing but here else. What is else here is nothing but return n into fact of n minus 1. So n into fact of n minus 1. So this is our factorial function writing mechanism using recursive functions here. If let's observe this one, int fact of int void main int n comma f here. Enter any number. Scanf percentage number, that is f equivalent to fact of n. Let us, for example, n is entered by user is 5. Whenever you call this function, control is passing to the function definition. What is function definition? Int fact of n value is copied into x. What is x value here? 5. So it's nothing but int y. If x equivalent to 0, when this recursive function has to be stopped, whenever x value is 0. Right now, what is x value here? 5. Equivalent to 0. Condition is false. Else. In else, what is x value here? 5. 5 into fact of x minus 1. What is x minus 1 here? 4. It's nothing but 5 into 4. 5 into fact of 4. Fact of 4 is nothing but again calling the function that is fact of 4. What is 4 value is copied into x. What is x now? 4. Again x. What is x value? 4. Condition false. Again else. What is x value? 4 into fact of x minus 1. 4 minus 1 is nothing but 3. Again what is x value here? 3. Again check it. Condition false. Again else. What is else here? 3 into fact of 2. Then again 2 equivalent to 0. Condition false. Else. Y equivalent to 2 into fact of x minus 1. Nothing but 1. Again this condition. Again this is condition is false. Again 1 into. What is x value here? 1. 1 into fact of x minus 1. What is x minus 1 here? 0. Now x is 0. This condition. What is x value here? 0. Equivalent 0. Condition is true. What it is returning now? 1. This 1 is written to the function which is called the x value as 0. Where it is called here 1 into fact of x minus 1. Nothing but 1 minus 1 0. Now it is written to this function called that is 1 here. That is nothing but. So last that is 1 into fact of 0. Nothing but 1. So right now what is y consists here? That is y consists of y equivalent to what is happening here 1 into fact of 0. What is fact of 0 is going to returning that 1, but 1 into 1, that is generally is a 1, but we'll get the factorial value. What is factorial value is 5. Factorial 5. What is factorial 5 is it should be written 120, but how it is going to return 120? Let's observe once again. Whenever you call this function, control is passing to the function definition. Now x is 5. Checking this condition, 5 equivalent to 0, condition is false. If it is false, coming to else. In else, whenever the recursive function is going to executing, the statement values are going to pushing into the stack memory. What is statement value? X. What is x value? 5. The 5 is going to pushing into stack memory. After pushing into the stack memory, now it is going to calling with the fact of 4. It is calling with the fact of 4. That is nothing but the y value has been pushed into the stack memory. Then again call this one 4. Condition false. Again x. What is x value? 4. This 4 is also pushed into the stack memory. What is 4? Y equivalent to already it has been pushed 5. Y equivalent already pushed 5. 5 into now it is going to pushing 4 into the stack memory. Then I can call the function with the fact of n minus 1, nothing x minus 1, nothing but 3. Again call this one. Again check this condition. What is the condition? X equivalent 0. Condition false. Else. In else again it is going to, what is the x value now? It is 3. 5 into 4 into 3 is pushed into the stack memory. Then again call this function with fact of 2. Then next time again x equivalent 0. Condition false. Again y equivalent to, what is y equivalent to? Already 5 is pushed into the stack memory, 4 is pushed into the stack memory, and then 3 is pushed into the stack memory. Now fact of 2 is pushed into the stack memory. Then fact of x minus 1. What is x minus 1 is fact of 1. Then again call this function if the condition is false. Else then y equivalent to x. What is x now? Already is pushed here. What is the values has been pushed here? 5 into 4 into 3 into 2 into 1 into fact of 0. What is fact of 0? Is returning that 1. So like this it is going to pushing all the values into the stack memory until the recursive function called stop. Once the recursive function call has been stopped, what is the recursive function has been called stop, then it is going to popping one by one value from the stack memory and multiply all the values and execute the statement. What is first time here? 5. So 5 is going to popping from the stack memory. Already what is y value? 1. 1 into 5. Next time 4 is popping from the stack memory. 5 into 4. Next time 3 is going to popping from the stack memory. 20 into 3. Next time 60. That is next time 2 is popping from the stack memory. 60 into 2. Nothing but 120. Next time 1 is getting from the stack memory. That is 120 into 1. Nothing but 120. So like this it is going to popping all the values from the stack memory until the stack is empty. After popping all these values, then this value is multiplied all the values and stored into the y memory location. Whatever the statement is there, that will execute here. If you put x plus here, then it will add all the values by popping all the values from the stack memory. If you put x multiplication, it will multiply all the values by popping from the stack memory. If you print, it will print all the values by popping from the stack memory. Right now our requirement is factorial value is multiplication whatever the values has been pushed into the stack memory. Like this it will pop all the values from the stack memory and stored into where it is going to storing. We are asking to be stored into y variable. Then after finally it is going to return the y. What is y now? 120. That 120 value has been stored into f, that we are printing now. Printf the percentage factorial is percentage n comma f. What is n value? Is 5. 5 factorial is 120. So this is a recursive function to be calculating the factorial value of the number. Similarly, we just try to write some more examples using recursive function here. Write a recursive function that is to be written the next Fibonacci value using the recursive function mechanism. Okay, what is Fibonacci series? We know that sum of the two preceding numbers is called as Fibonacci series value. So that is Fibonacci of n. If n value is 0 or n value is 1, the next Fibonacci sequence value is 1. Otherwise, what is this one here? Written Fibonacci of n minus previous value plus Fibonacci of n minus two value. We just try to write this function to be written in the Fibonacci series value to the next Fibonacci series value of the given number here. So that is next function also. You just try to write a function to be written the GCD of two numbers. GCD of two numbers using recursive function here. Using recursive function. Just try to write this function also to be returning the GCD of two numbers using recursive function. What is GCD? Nothing but greatest common divisor. Say let us for example, if we give a is some 9 and b is 3, nothing but a is the greatest common divisor. A is 6 and b is 36. 6 is the greatest common divisor. Similarly, a is 25 and b is 0 for example. Then written the greatest common divisor is a. Is nothing but if greatest b is 0, then the greatest common divisor is called as a. If b is 0, then the greatest common divisor is a here. So what is your requirement is the recursive function has to be stopped when the b value is 0. So when b value 0, what you have to return that a value. So that is nothing but if b is equivalent to 0, then you should return the a value. Otherwise, that is return GCD of b comma a modulus operator b. Say let us for example, if you entered a is 3 and b is 9. So what is going to happen here? First time. What is first time? A is b. What is b value? 9. 9 comma a modulus b. What is a modulus b? 3 modulus 9. What is 3 modulus 9? 3 modulus 9 is 3 is not divisible with 9. So we will get the 3. Nothing but so this is 9 and as well as this is 3. These two values will pass. Next time, what is happening here? B. A is 9. 9 modulus b. What is 9 modulus b? Is nothing but 3. So this value will get 0. So that is b value is 3. So 3 comma 0. 3 comma 0 means so 3 comma 0. Now this is get like this. This is 3 and this is 0. If b is 0, b is 0 is nothing but written a. What is a? 3. So this is like this. It will calculate the greatest common divisor between the two numbers here. So like this, you can write another example also. That is, write a function to be written the sum of the digits of the given number using recursive function. Write a function to be written the sum of digits of the given number using recursive function mechanism. So like this, you can just practice more examples using recursive functions mechanism, and we'll discuss some more examples using recursive functions in data structures programming. So users, if you like this video, please like and share, and for more updated videos, please subscribe our channel. Thank you one and all.